Alright, so our first set of notes is going to be for section 1.3, which is points, lines, and planes. It's fairly simple material, so hopefully no one will have a majorly hard time with it. Our whole objective is basically for you guys to come out knowing what a point is, what collinear is, those type of definitions, because they're going to be used throughout the course. So the first thing is, what's a point? So it's a location, and there's no size. It's represented by a dot and a capital letter. So a location make these tiny little spaces for you guys. And it's horrible. And it has no size. It's represented by a dot and one capital letter. Now, it's imaginary, okay, so it's not literally a dot, but it's a point in space somewhere. And then that brings us to what space is. Space, in this instance, is a set of all points. So if you take all the points in the world and put them together, that's what space, kind of like all the stars. Now, a line is two or more points that extend in two opposite directions without end. So two or more points. Now these definitions build upon each other, so it's important to know what they all are. Oh, this should say, sorry, we already have the word point there, it should say collinear points. So let me erase that and put collinear. Collinear, the definition's near the bottom right here. Collinear means that points are in the same line. So when we do a line, we have two or more collinear points that extend in two opposite directions without ever ending. They go on and on and on and never stop. So going back up here, we'll draw a little representation. Okay, there's a point. Space, we usually draw like a parallelogram area and, you know, draw some points in there. So we could call this point A, and we could have point A here and point B and so on. A line is this right here. Notice you have arrowheads pointing in opposite directions. The reason why they're arrowheads is it's showing that they're both going in opposite directions and it doesn't end. There'll be little line segments that only have one arrow or no arrow, and those have different names. So our first example that I'm going to just show is line AB, how you can name that in two distinct ways. So draw that line segment with a double-headed arrow and draw an A and a B. You can name this basically in 5 different ways. So we can name it line AB, we can name it line BA, and I'm making it with the actual word. We can name it as without the name line in there, but we can show it with symbols, AB with a double-headed arrow on the top, or the same thing but the letters are reversed, BA. Or we could simply, if we have a little T, that's a T, like kind of like a italicized T, we could call this line T. So those are the 5 ways we could name this line. Now you can't name all things like that, but with lines, since they go in opposite directions, it doesn't matter if we go from B to A or from A to B. Either way, it's going on and on forever, and it's not going to stop regardless. Alright, so moving on up. We have this picture, for example, too, just as some practice. You should pause me at this point and see if you can identify the answers to A through D over here. And if you can, like these right here, then that's great. When we go over the answers, you'll know how you're doing. So I suggest you pause me, answer the questions, and then play and see if you get it right. So our points E, F, and C collinear. So are they in the same line? So we have point E, point F, and point C. Well, they form a triangle, so I'm going to say no. Are points E, F, and D collinear? Well, let me clear that. So E, F, and D, there's E, there's F, and there's D. They are on the same line, and that line is called N, right there. Are points F, P, and C collinear? Well, let's check it out. E is right there, P and C. No, definitely not. They're either on line L or M. So no. And what's another way to name line M? Well, line M is right here. So we could call that line CE because of the letters, or EC, doesn't matter. So CE with the double-headed arrow on the top, or EC. Alright, so now on to planes. Not an airplane, but if you think of the Great Plains, you maybe studied in social studies, it's basically a flat surface with no thickness. It contains many lines, extends without end in all directions, and can be named with a single capital letter or using 3 non-collinear points. Now keep in mind, a plane doesn't physically exist, neither does a point or a line, but we have these ideas of what they would be, and that's what it is. So it's not like tangible, you can't touch it, okay? It's kind of like a figment of your imagination. So one more time, it's a flat surface. Oh, keeps moving on me. There we go. So a flat surface with no thickness. Contains many lines, infinite many. extends without end, in the direction of all its lines. It's named by a single capital letter, or by using 3 non-collinear points. So either way is fine. So non-collinear means they would not be in the same line. Alright, so, and that's like that parallelogram thing that we drew above in the very beginning right here for space. Alright, coplanar. It's points and lines on the same plane. Okay, so just like collinear were points on the same line, coplanar can contain points or lines, which would make sense since lines are made up of points. So, points and lines in the same plane. Alright, so we have some examples. Maybe if this thing will move up. Oh, it's because I need to go on the next page. So, name each plane. In this case, it's a point with a capital letter, so that would be plane P. In this case, it could be plane ABC, CAB, or BAC or BAC. It doesn't really matter, but usually we go in alphabetical order. You just could not name it. Say for instance we had another point right there and we called it D. You could not name this plane ADC or CDA because these three are like collinear points, and it'll be easier for me to show you in class, but if you think of 2 index cards and you make, it's going to be a horrible drawing so I'm going to apologize now. You have one index card here, and say you cut a slit in the index card, and you took another index card and you stuck it in that slit, so you kind of have, like, it's not going to look good at all because I can't draw 3-dimensional. You have like this other index card that's going through that slit. That's why you cannot use collinear points to name a plane, because if you did that and say this was the slit right here, we could stick another index card in slit ADC and we wouldn't know if you were talking about this plane down here or that vertical plane that's coming up through the paper that goes through this slit. You wouldn't know if you were saying to somebody, hey, plane ADC, they wouldn't know which one you're talking about. So that's why they have to be non-collinear. So you can't have that situation. Alright, so I'll demonstrate better in class, but maybe you can, for you visual people, you could get a grasp on that. A postulate or an axiom. This first half of geometry is going to be filled with postulates and axioms, and then theorems. So you're really going to have to remember them, all of them, because you'll be using them in proofs. And you really can't just kind of disregard them like you may have done in the past with definitions. They're extremely important. So basically those are statements that are accepted as a fact and you do not need to prove them. They're actually the foundation of your proofs. You got to start somewhere, and that's where you start. So it is accepted fix that. It's really hard to write because I can't touch the iPad because this program does not have like a wrist guard, so when I touch it, like how you would write on paper, it makes marks in the bottom. I can show you, see down here, how it made that mark because I rested my wrist on the paper. So that's why I'm hovering the pen over and writing. And does not need to be proven. Okay? So the first postulate, now it's not known as postulate 1-1, that's not its name, but it's the name in this book because it's the first postulate in chapter 1. So that's where 1-1's coming in. So through any 2 points there is only one line. So through any 2 points you will only be able to draw one line. So an example, if I gave you 2 points, you could basically draw them anywhere on the paper. I'll say A and B, okay? A there, B there. Anywhere you want. You don't even have to, you can pick whichever, if you want to draw C up there, whatever. To connect A and B, there's only one connection. You can't make another connection. It's the same line. Okay, so that's why that is. So for theorem 1-2, it says if two lines intersect, they intersect at exactly 1 point. So if two lines intersect, then they intersect at exactly 1 point. Okay, a picture of that, if I had two lines, let me move this up. Maybe we'll just draw it right here. So I have two lines, and I'll call them AC or AE and DB. Okay, so those two lines that intersect, so if you want to, wherever you want to make them intersect, that's fine. But regardless, you're only going to have one spot where they cross. And we'll just call that the missing letter C. Okay, that's postulate 1-2. Now if you guys remember from algebra, or if you've had algebra 2, remember when you had systems of equations like y equals 2x plus 3 and y equals 1/2 x plus 4. When you solved, when you graphed those, they crossed. And the location that they crossed, that's a demonstration of postulate 1-2. Alright, postulate 1-3. Postulate 1-3 says if two planes intersect, then they intersect in exactly one line. So if you have two planes, so like two index cards, like my drawing before, and they intersect, then they intersect in exactly one line. Planes intersect in lines, lines intersect at points, and points don't intersect. And here's an example, the index card example I was trying to demonstrate and I did so poorly at. So you have your two index cards that are intersecting. Index card or plane, we'll call RST, notice they are non-collinear, and plane WST. Well, if you write these out, plane, and this won't always work because they might name them if there's a fourth line or a fourth point, it won't work out this way, but a lot of times it will. In plane RST, these guys intersect in this line right here. Hopefully you guys can see that. This is the line in which they intersect, line ST. And notice what they both have in common in their name. So that's a good indication of how you can figure out which one or what location something crosses if they share a common point or line. However, you have to be careful because in some of these examples they'll give you 4 points and they'll use one of the points that is not common. So if we threw an extra point down here and just called it X, then I could name one of these, namely the RST one. I could name, instead of saying RST, I could name this RSW. Or I'm sorry, RSX, not W. So then you wouldn't have the ST as a common, you would just have the S. So be really careful in that aspect. But a lot of times it works out. Alright, and then postulate 1.4 says through any 3 non-collinear points there's exactly one plane. So through any 3 non-collinear points there's exactly one plane. That's basically a cube. Or I'm sorry, that's the next question. That's just like through any 2 points there's exactly one line. Any 3 points that you give a person, they can always draw a plane in it. So our cube here, if we labeled these F, these little corners, G, C, B, E, H, and AD. You should pause me here and see if you can answer questions 1 through 4, and then unpause me and see if you got them right. So go ahead and pause me now and see what you can do. So shade the part that has A, B, and C. Well, that's already done. That's shaded for you. So that was question 1. Question 2, shade the part that has point H, E, and C. So H, E, and C, this is tricky because it's not like a side of the box, it's actually inside the box. If you could imagine cutting diagonally through the box so you have a triangle on top and a triangular piece on the bottom, then that would be that plane. And if you looked at it sideways, it would be one big rectangle. If you looked at it from sideways and above, this piece would be that piece in there. Number 3, what is another point of ABC? Well, here's here's E. Here, oh no, we are doing ABC. I'll get it right. As soon as I get my pen. ABC. A, B, C. Let me erase my missing line here. That won't let me know. Alright, so ignore that E because it's not supposed to be there. So the other part is the other corner D. So we want that. And name a point that is coplanar with points E, H, and C. So let me switch up the colors here. So here's E, here's H, and here's C. Well, B is the only one that touches that plane that we said here. So this would be like E, H, C, and this is B right here. So B is the answer. Now this question will be on a test. It'll probably be like an essay. What in your room, wherever you're at, represents points, lines, and planes? My best idea I can give you is where your ceiling and your wall meet. So you have your ceiling there, or your floorboard and your floor, the wall and the floor, however, whichever way, they're the same. And say there's your wall. I'm a horrible drawer, I know. It's terrible. So there's your ceiling, there's your wall. This is a line. Okay, so the ceiling and the wall meet at a line because they're considered like planes. Your floor and the wall meet at a line. As far as points go, if you can look at the corners of your room, those would be like considered points where two lines meet. And yeah, we got all three. So that pretty much wraps up a lot of definitions for section 1.3. So this assignment might change a bit. It won't change a whole lot, but I'm going to have to take a look and make sure that we have the problems that we need. So you feel free to work on it if you want to. By no means do you need to. Just be ready for a quick quiz type of deal, so I know that you guys did what you're supposed to do.